So graphically solving the convolution integral, this consists of time reversing one of the signals, shifting it, and then multiplying it point by point with the second signal and integrating the product. So for the graphical method, here are the steps. The first is folding. So we choose one signal to fold, and then displacement, so shift of delay, and then multiplication, so find the product of the two signals and then integrate for a given time t to get the y of t at that certain uh, range of t. So to better understand the steps in solving for the convolution of two signals, we will have an example. We have x1 of t and x2 of t. So first step is to fold. This signal is this signal x1 of t is much more convenient to apply the fold and shift. The first step is to fold or mirror and then shift x1 of t. So after folding and shifting the first signal, we shift this first signal to different intervals of t and then multiply it to second signal and then integrate. So for the first interval, for time from 0 to 1, the convolution of two signals is equal to 0 since there is no overlap between the two functions for A. For B, time interval from 1 to 2, the two signals overlap between time 1 and up to t. So looking at the figure, the two functions uh, overlap at the shaded area. So between 1 and t, we have integral from 1 to t. The value of the first function is 2 times the value of the second function is 1. And we have d tau. Evaluating this integral, we have 2 tau evaluated from 1 to t equivalent to 2 times the quantity of t minus 1. So for figure C, for for time interval 2 to 3, you look at the figure, the two signals completely overlap between t minus 1 and t for looking at the shaded area. We have y of t equal to t minus 1 up to t. The value of the first function is 2, second function is 1 tau. So we have 2 tau evaluated from t minus 1 to t. We have a constant value. Third interval, we have from 3 to 4. So the two signals overlap between t minus 1 and 3. So we have t minus 1 up to 3. We have the value of first function, second function, t tau equal to tau related from t minus 1 up to 3 equal to 8 minus 2t. Then for the last time interval, we have t greater than 4 4. So the two signals do not overlap, so y of t equivalent to, so we obtained values of t at several time intervals. We have 0 at time interval 0 to 1. We have 2t minus 2, 1 to 2, and we have 2 time interval 2 to 3, and we have 8 minus 2t from 3, 4, and we have 0 t greater than equal to 4. So graphing the response y of t, we have this figure. So another method in finding the convolution of two signals is getting the Laplace transform of each signal and then multiplying the two, we get the Laplace of the output response, and by converting it to the time domain, we get the output response in time domain. So first, let's get the an equation for the x1 of t and x2 of t. So x1 of t equivalent to 2 u of t minus 2 u of t minus 1. And for the second function, we have u of t minus 1 minus u of t minus 3. So the Laplace transform of the first function is equal to 2 over s minus 2 over s, and we have a time shift of e to the negative s. Or this is equivalent to 2 over s 1 minus e to the negative s. And for the second function, we have 1 over s with a time shift e to the negative s. We have minus 1 over s and the time shift. We have e to the negative 3s. Getting y of s, we'll multiply the two functions. We can write this 1 over s times e to the negative s over s times 1 minus e to the negative 2s. Multiplying the two functions, we have 2e to the negative s over s times, we have 1 minus e to the negative 2s minus e to the negative s plus e to the negative ts. So distributing 2e to the negative s over s, we have 2e to the negative s over s minus, so we'll rearrange this term right here. We have 2e to the negative 2s over s minus 2e to the negative es over s plus 2e to the negative 4s over s. In the time domain, this is s squared. Getting the time domain, we have time shift, so this is 2 times t minus 1 u of t minus 1 minus 2 of t minus 2 u of t minus 2 minus 2 t minus 3 u of t minus 3 plus 2 t minus 4 u of t minus 4. So is this equivalent to this function? So we can express this equation as 2t 4 u of t minus 3 plus 2 t minus 4 u of 4, and combine these terms and these terms. This is equivalent to 2 t minus 1 u of t minus 1, and we have minus 2 t minus 2 u of t minus 2. We have minus 2 t minus 3 u of t minus 3 and plus 2 t minus 4 u of t minus 4. Now our phi of t. Looking at this expression, and this expression, so they are